You haven't done this one, right? Kenapa dia macam ni? Okay. Okay, let's do this question. Please read it first while I erase this. Lutfi, betul, Lutfi, okay, 13. Okay, read the question. Oh wait, there is one more thing that I forgot to recap with you guys. If I have, okay. So I have a beam and this is my axis of rotation. I have a force here, F1. I have a force here, F2. I have a force here, F3. So to find the net torque, right, I have 3 torques that I have to add, okay? 3 torques that I have to add, and remember your length of R is from the axis of rotation. So this is your R1. And for your F2, your R is this one. That's your R2. And this one is your R3. So now you have 3 theta, right? You also need to know what is the direction. And I told you if it's going clockwise, it is negative. And if it's going anti-clockwise, it is positive. So for your net tau, not your net torque, let's just stop saying tau. Your net torque, your F1 is going clockwise, so it's a negative. Okay, how do I know? Because I'm a pro. No, I'm just kidding. I already like imagine it in my head. Okay, so it's a negative, and F2 is negative as well. It's going clockwise. That's R2. And then plus with your F3, which is R3, right? So that's your net torque. You have direction for torque. And then when you know what the answer is, let's say this is negative 10, this is negative 20, this is negative, yeah, this is positive 30. So your final answer is a positive, no, it's not positive, it's 0, right? It's 0. Okay, so if my answer is 0, which way am I going?
Not moving.
Not moving. I'm in equilibrium, right? So I'm not moving, at least not rotationally. Okay, I'm not rotating. Okay, but if I have a positive answer, I will go anti-clockwise. My beam has forces yang lagi kuat lah. My torque, my net torque is pushing upwards, which means that I'm going anti-clockwise if it is a positive. So this is going anti-clockwise direction. And what is the unit for torque? It is, F is Newton and R is meter. You don't have to memorize it, just look at the equation. Provided that you memorize the equation. Excuse me. Oh, bencinya. Okay. Oh, let's do this example. Okay, let's start. Padang balik.
Dr. Nat?
Yep.
Since the unit for torque is in Newton meters, so can we use joules?
I haven't seen torque as joules before. Let me check back on that. Once I can check torque, apa lagi saya kena check hari tu, saya lupa dah sebenarnya. Let me write that down here. Can torque be written as joules? Okay, so that's for me. That's my little note for me to check back on. Okay, let's do this question. 4 objects. All right, you're welcome. 4 objects are held in position at the corners of a rectangle by light rods. So benda Allah ni sebenarnya rods lah. Yeah, they are rods. Okay, but they lukis as a line je, but actually it's rod. As shown in the figure, find the moment of inertia. We learned that moment of inertia is I, right? I is mr squared, but this equation depends on the object. So you always have to, I would say memorize, but right now you haven't memorized it. So always check back your module to see what is the equation. Find the moment of inertia of the system about the x-axis and the y-axis. Okay, I want us to discuss this question. What does it mean? Okay, so I'm going to ask someone to help me. Can I get Balkis Ashik? Are you there, Balkis? Balkis ada
Yes.
tak? Okay, Balkis. Remember that our torque, right? Our torque punya equation is RF, right? And the
Yes.
R is from the length of R is from
the X for the axis of rotation.
okay, axis of rotation sampai ke
Sampai ke mg.
sampai ke force, right? Okay, so
Sampai ke
it's
force.
from the axis of rotation to the force applied. Okay, betul. Sekarang ni soalan cakap find the moment of inertia of the system about the x-axis. So if looking at this diagram, right? Where is my x-axis? It's here, right? It's here. This is my x-axis. Now, kalau saya nak cari the R for my 5 kg, this 5 kg, what is my R? This is my y-axis and this is my x-axis. What is my R for this equation? Tadi kita cakap R tu the length from the axis of rotation to the applied force. But what is the R in this case for the 5 kg?
Is it 3?
Yes, betul. Thank you, Balkis. Betul. So
Okay,
here the
better.
R, yep, the R is from the axis of rotation to the applied force. The applied force is the weight of this guy lah. But in this case, itu kalau cakap pasal torque. Now we are talking about I. So I cares about mass times the length of object or the mass. No, the distance lah basically. The distance between the mass and the axis of rotation. The R is the same as torque. Distance of mass, but in this case it's mass. Mass to axis of rotation. Okay, so Balki said it is 3 and she is correct. Okay, so if my axis of rotation is Y, what is the R? Can I get Husna to tell me? Husna, are you there?
Sorry, Miss, what was the question?
Okay, so my mass is 5 kg, this particular 5 kg. What is my R if my axis of rotation is Y?
Two.
2, betul eh? So it's 2. Okay, so from the, even though your axis of rotation is like super long, just take the nearest one, right? So this mass is here, the nearest one to the axis of rotation is here, so it's 2. Don't go all the way here, okay? Because yes, that's your axis of rotation, but that's not the closest one. So take the closest one, which is over here. Okay, so your entire y-axis is your axis of rotation. If I have a mass over here, the axis of rotation is y, my R is here. Okay, so because the axis of rotation is the whole thing. Okay, is that clear for everyone? Okay, ke? Okay. Sarah Amani, do you have any question for me? Okay ke? Sarah Amani, are you there?
Yes,
Okay. Tak ada soalan eh? Alright, so let's start on this problem. Can I give everyone 8 minutes to do this on your own? And I'm going to call someone to tell me the answer, okay? 8 minutes. So let's come back at 8:34. 8:34, yep. 8:34, I'm going to call someone. Okay, try it on your own first. 8:34 a.m. Okay, if you have any questions, please feel free to ask. Okay, the rest of you can start. Tolong buat nanti exam tak tahu nak buat. Nauzubillah. Harap-harapnya boleh.
Doctor,
Yep.
so for this case, we don't know the axis of rotation or we get assume.
No, we don't have to care about the rotation here because moment of inertia only wants to find the equivalent mass in the angular world, right? This is like a pre-step before you find torque.
But we also need to find the R, right?
Mm-hmm. For this one, you have to find the R. So remember, torque has two equations. It's RF and torque equals to I alpha. So if you were to use I, this dude already has the R. So if you want to find torque, you just multiply it with alpha lah, the angular acceleration. They already counted in for the R. Okay, so that's the purpose of finding the moment of inertia.
So the R also must refer to the axis of rotation. Okay.
The R must also be from the axis of rotation. Betul?
So kalau soalan ini tahu axis of rotation, how will we find the R?
Macam mana lagi sekali? If they,
Question, we don't know which point is the axis of rotation, so how do we get the R?
for the R in the, for example, hari tu kan, kita dah belajar, sorry saya tukar soalan jap. So we need to find the axis of rotation on our own here, right? So in some cases, they give you the axis of rotation. And in this particular example, they give you the axis of rotation. But sometimes they don't. So your R is dependent on your axis of rotation lah. Okay? Kena tahu. Either you have to know it by buat sendiri, figure it out using a ruler or something, or they tell you where is the axis of rotation. Okay? Memang boleh ada soalan macam tu.
Dr. Nat, in the case that they don't give us an axis of rotation, then when we use the ruler, do we have to find the midpoint?
Untuk soalan macam ni, they will tell you lah, because assuming the X and Y tak ada kat sini, this picture is very, it doesn't give you information lah. It's not a real world punya diagram. If they were to ask you to find the axis of rotation, I am sure that it's something from your daily life. Contohnya macam
That means there'll be something between the lines for us to refer.
something between the lines to refer.
Like contoh the situation where the human arm, so like that is the
Yeah.
point.
Something that you can relate to lah.
Thank you, Doctor.
Right. Don't worry, benda macam ni macam very generic, selalunya dia akan bagi tahu lah. Okay, 4 minutes to go. Nak suruh siapa Okay, for the answer, can I get Reza and Saharul? Reza for x-axis, Saharul for y-axis. Are you guys there?
Yes.
Okay, siapa tu?
Reza.
Okay, Reza, your x-axis, right? Okay.
For x-axis,
Hmm.
I do 5 times 3 square plus 4 times 0 square plus 3 times 0 square plus 2 times 3 square.
Ya, nak tulis. Lagi sekali.
Oh,
5
5
times
3 square
3 squared. Hmm.
plus 4 times 0 square
Okay.
plus 3 times 0 square
Okay.
plus 2 times 3 square.
Okay, thank you. Saharul? Three. Okay, third. What's the unit for I, Reza?
Kg meter square.
Yep, thank you. Saharul, are you there? Tidur ke?
Sekejap doktor sebab tadi saya lost connection. So,
Okay. Okay. Sekejap. Mana pergi pen? Did everyone get the same as Reza? Jalan kiri dia?
Yeah.
Alright.
Sama.
Can tau be written as joules? Tau negative. Okay, Saharul. What's the answer? Nak jalan kira je.
Doctor,
Yep.
I don't really understand how to find the x-axis one.
Lagi sekali Mazen, tak dengar.
Not understand about how to find the answer for x-axis. Why is there two axis of rotation?
Oh, no, there's only one. This is A if the x-axis is your axis of rotation. And then a second situation, if the axis of rotation is Y. It's just kalau lah, if it's an if situation. Tak boleh selalunya, tak boleh ada two axis of rotation. Okay, it just wants you to understand how to find moment of inertia. Okay, Saharul, senang je ni, jom kita buat sama-sama.
Thank you, Doctor.
Okay, welcome.
Bye.
Okay,
5
5 times
times 2 square
2 squared, betul, and then
plus
2,
plus 2 darab
2 ni
2
dekat
square
mana?
2 square
Okay, betul je. Okay, and then 4,
plus 4 2 square
2 squared,
plus 3 2 square.
okay. So what's the unit untuk I, Saharul?
Kg meter square.
Okay. Alright, I hope everyone got the same answer. Okay, jalan kira kena sama. Kalau korang salah tekan calculator, tu salah korang lah. Okay, but this is how you find it. Okay.
Dr. Nat, for IX, do we have to show the 4 times 0 squared and 3 times 0 squared?
No, you don't have to. You can just not write it down. Boleh tak tulis
Thank you, Doctor. Doctor, also I found out for torque, if we want to use joules, then the actual derived unit is joules per radian.
Oh. Tak payahlah pakai Newton-meter, dah lah.
Yeah. But to make life easier, physicists recommend the use of Newton meters.
Okay, yeah, that sounds about right. Okay, to make your life easier. All right, so let's move on. Next one. Okay, so please read the question while I try to erase this quickly. Excuse me. What time is it now? Okay. Okay, read the question. What does it want? Okay, a grinding wheel. So what is the MR squared? It's a solid cylinder, right? The I is a solid cylinder equation. It's a uniform cylinder with a radius of 8.5 centimeter. You have to convert this to SI unit always. And a mass of 0.58 kilogram. Calculate its moment of inertia, I, about its center. So your cylinder, sorry about the diagram, the axis of rotation is about the center. So if you were to refer to the internet or in your module, make sure that the I that you are referring to has the same axis of rotation, right? Because the axis of rotation can change. And then the net torque needed to accelerate it from rest to 1,500 RPM in 5 seconds. If it is known to slow down from 1,500 RPM to rest in 55 seconds. Okay, so this slow down from 1,000 to rest. Okay, so it's asking you to find the net torque. Okay, so please take 7 minutes to write down the equation. Just try to write down the equation first, and then we will discuss it. Check your book, how should it be done? Okay, kena buat sendiri juga. Okay, saya nak excuse me. Saya nak tanya untuk I dululah sebab I senang. Excuse me, Ish, I need to mute. Okay, tanya siapa? Faiz, nak tanya Faiz lah. Faiz, what's the I for a solid cylinder? Where's Faiz? Faiz, are you there? Faiz has gone to La La Land. Where is Faiz? Okay then, if that's the case, can I get Vasan?
Yes, miss.
Okay. What is the I for a solid cylinder with the axis of rotation in the center, at the center? Boleh
1
refer
or 2.
tengok buku, 1/2?
1/2 MR square.
Okay, oh, sorry. And what should be my M? What should be my R?
M 0.58.
Okay.
0.085. 0.08.
Okay, thank you. Okay, so we are left with net torque. Okay, so can I get Meon to help me with the net torque? Okay, Meon, what should we do to find the net torque here?
Net torque. Nak cari net torque eh? Net torque is we times the moment of inertia with acceleration.
Okay, so how do I find the acceleration here?
So how we find the acceleration here? It's already wait
Okay.
wait yes.
Kat sini ada dua acceleration kan?
Do acceleration.
So it means that you have two torques, right? So net torque is the summation of torques, right? Torque 1, torque 2. Torque in general is I alpha 1 and torque 2 is I alpha 2. So what is I alpha 1? What is alpha 2? Di sini
So,
ada.
Uh-huh.
Okay. Okay. Mion cari saya alpha 1 sekejap. In 5 minutes. Lagi seorang cari alpha 2. Sekejap saya cari pembantu awak. Siapa nak jadi pembantu dia? Akil lah. Akil boleh? Akil tolong cari I2. Sorry, alpha 2. This is alpha 2. This is alpha 1. Okay, Mion alpha 1. Akil alpha 2. Okay, anyone? Akil? Dah settle ke? Okay, Mion, what is 1,500 RPM here?
1,500 RPM equal to 100
100.
57.08 radian per second.
Okay,
Point.
so point.
Second. So we already got his omega. How to find acceleration is omega change of omega over time.
Okay.
So our final is 157.08. Our initial is 0. So let's conclude 157.08 over 5 seconds.
Okay, correct. Betul. Okay, the
That
answer is?
will give us 31.416.
Unit?
Ini radian per second per second.
Yes, radian per second.
Radian per second per
Right.
second. Alright, thank you.
Okay, thank you. So betul Mion buat tu. So initial omega is 0. So it's the final. Okay, so Akil is next.
Doktor nak make sure memang wajib kena tukar pada radian per second.
Kalau awak tak tukar nak buat macam mana?
Okey, faham.
Dah faham dah?
Wajib.
Okay, so Akil.
Delta omega 0 minus 175.08.
Delta omega is berapa?
Negative 157.08.
Okay. Over?
Divide by 55. 2.86. Negative 2.86 radian per second square.
All right. So now that you have, thank you Akil, thank you Meon. So now that you have two alphas, which means that you have two torques, right? So the first torque, the I is still the same, it's the same cylinder, but the first instance, the first alpha, it is speeding up, it is accelerating. And then the second one, it is slowing down. So what you can do to find the net torque is just add these two torques together. So if I want to do this betul-betul, because kalau saya tak tulis betul-betul nanti mesti ada orang tanya, Doktor macam mana nak buat sebenarnya? Walaupun jawapan dia agak straightforward. Okay, tak apa, saya tulis je. So here, what's the answer for I? Lemak tak kira pula. So that is 0.58 times 0.085 squared divided by 2. And that is 2. Betul ke ni? Ya, betul lah. 2.09, 2.1 je lah. Malas. 0.10 times 10 to the minus 3. That's your I. And your alpha is 31.42. Right? So that's your first torque. And this guy is a positive. The second one is 2.1 times 10 to the minus 3. Same I, because it's still the same cylinder. And then the minus alpha 2 is minus 2.86. Okay, so that's your second torque. And this guy is a negative because this guy is negative. So I don't know what the answer is. Kejap. So this guy times with 31.42 minus 2.86. So what's the answer? What's net torque?
0.06.
0.06. And the unit is Newton meter. So the net torque to have these two situations is 0.06 Newton meter. Okay, let's try to understand why. The net torque needed to accelerate it from rest if it is known to slow down from, sebenarnya nak kata this is the first situation sebenarnya. This is the first situation. It is known. Kita dah tahu yang dia ni tengah decelerating. Dia tengah slow down. Tapi saya nak dia jadi laju balik. So apakah net torque yang saya perlu letak kat dia? Apakah net torque yang saya perlu kenakan dekat silinder ni supaya dia rotate accelerating. Dia rotate accelerating. Sebab sekarang ni dia tengah decelerate, dia tengah slowing down. Okay, dia tengah slowing down, dia makin berkurang rotation dia. Saya nak dia jadi laju balik. Laju balik. So apa net torque yang saya perlu kenakan untuk bagi dia jadi laju. Okay, so itu yang soalan dia suruh buat lah sebenarnya. So the net torque is 0.06 Newton meter. Okay. Sorry. Okay, next example. Do we still have time? Okay, kita go through soalan je dulu. A uniform wooden beam that is 3.2, kita buat free body diagram terus lah. So wooden beam ni saya dah parking dekat tepi ni. Anggap sebelah ni is your wall. And this is your lantai. Okay. A uniform wooden beam that is 3.2 meter long and mass of 20 kilogram. So mass of 20 kilogram. Saya nak tanya siapa? Saya nak tanya Bell lah. Bell, where should I place my force? From mass. From where should I place my weight?
Weight should be at the center of the beam.
Yes.
Downward.
So downward, and it should be at the center of the beam. So this is weight. Okay, weight of beam. Okay, what should your weight of beam be? It is 20 times 9.81. It is equal to mg lah sebab weight kan. Okay, so it is at rest. So that is your other condition. It is at rest. So this, you know that it is in equilibrium. Okay, and this is the length. Okay, with its upper end against a smooth vertical wall. Smooth, eh? So this guy is smooth. So your wall is smooth. Maksudnya tak ada friction. And its lower end on a rough floor. So ada friction. So tapi kita tak tahu lagi friction dia arah mana. if the angle it makes with the floor is 50 degrees, so 50 degrees, calculate the reaction forces at both ends. Excuse me. What is the coefficient of friction of the floor? Okay, so we already know that our force, weight force is here. Do I have a reaction force over here? Do I?
Yeah,
Why, Hakim? Excuse me.
it's touching the wall.
Okay, apa tadi Hakim? Sorry, tak dengar.
Sebab dia ada kontak wall.
Sebab dia contact. Is that your answer? Dia putus-putus lah.
Sebab dia ada kontak dengan wall.
Okay, thank you. So betul. So does this guy have R as well? Yes, it is in contact, right? So I don't know the direction of R sebenarnya. I'm just guessing. Okay. Okay, so let's imagine a ladder. Sorry, saya cik batuk je hari ni. Batuknya dah okay dah. Okay, I need you guys to see me. Sekejap. Saya harap tak ada orang tak.
The R doesn't need to be like having an angle. Yang dekat bawah.
Betul. I told you the R should be having an angle, right? So tapi saya tengah lukis randomly. Okay, let's have that angle. I just put it there. Let's say the angle sikit. Ada angle sikit. Okay, so that's R1, R2. Okay, who knows what the angle is? Okay.
Dr. Nat, maksudnya for this chapter, in every situation, we have to assume R has an angle unless it's stated that it doesn't have an angle.
Wait, this is due to contact force, right? Ni bukan axis of rotation. Wait. Need to look back at this one. Okay, jap. Kita determine our axis of rotation dulu. So for this beam, right, look at me. Kena nampak ke? Where's my mouse? Okay, it's here. Okay, so look at me. This is the beam. And if my beam has a rough surface, maksudnya dia akan cuba halang daripada bergerak, right? It has a rough surface, dia akan cuba halang daripada bergerak. And then this wall is smooth. So if I were to rotate, would I rotate like this? Would I rotate? Kenapa hilang pula? Would I rotate like this? Or would I rotate like this? The first or the second situation?
The second situation.
The second situation. Why? This is a ladder on a wall. Does your ladder do like this?
No.
So this guy becomes the axis of rotation. Is that the case? Nothing is gripping it here. So how is it like that? Okay, again, so my wall is First one.
The point that touches the ground will be the rotation axis.
Because?
Rotation. Because of the
rough surface, right?
Rough surface.
Right.
So
correct.
it will be.
So it will be.
It will not move lah.
It will move. Okay, axis of rotation selalunya tak bergerak kan? Bukan selalunya. It will not move. Okay, because compared to the rest of the body, the rest of the object, the axis of rotation je yang sepatutnya tak bergerak. Okay, because it is the axis of rotation, because that is where you rotate. So if this guy is rough, it will have an anchor lah, somewhat anchor to give that ladder that rotation if it wants to rotate lah.
Doktor, dia boleh bergerak macam tu ke? I mean, like, the force on D yang ada kat sini adalah weight dia je, which is ke bawah. So bila dia gerak macam tu, dia against that force.
Okay, against that force. Oh, mak aku jatuh. Against that force,
Dr.
betul.
Do you
Yep.
mind showing the two simulations again? The pergerakan.
Okay. So, pergerakan yang pertama is if my if my bawah ni is the axis of rotation. So dia akan jatuh macam tu lah. Jatuh macam tu. Okay, macam tu. Dekat wall. It goes like that. It goes ke bawah, ke belakang. Which happens in real life, right? And in this case, the second situation, the wall becomes the axis of rotation. So jatuh. Dia jatuh macam tu lah. Dia jatuh macam ni lah kan? If this is the axis rotation.
Doctor, that means the beam like terapung. It gets suspended in the air.
Yeah, dia terapung lah.
Doctor.
Yep.
Sorry for interrupting, but our
Oh, dah terbit masa, yes.
English miss already call us to go into the Zoom room. So for BI.
Okay,
So
sure. Alright, so bye-bye guys. Kita sambung kemudian Bye-bye. Apa kita sambung example ni?
Nak kata basically situasi ni macam tangga disandarkan kat dinding.
Yep.
Okay.
Alright, bye. Bye korang.
Okay, Doktor.
Thank you, Doktor.
Okay, welcome.
Thank you, Doctor.
Go. Nanti kena marah.